somewhere at the very edge of the observable universe, in an era when space was just beginning to be filled with the first stable structures, there is an object whose light bears traces of time, almost inaccessible to the imagination. JADES-GS-z13-0 is not just a point in the deep sky, but an imprint of the era when the cosmos was just beginning to form its first complex shapes. This light has traveled billions of years of expanding space before reaching modern observational instruments. It came from a time when the universe was younger, denser, and much more energetic.
At that time, there were no familiar large-scale galactic structures like those that dominate in later eras. Everything was in the process of assembly, in a state of continuous cosmic becoming. JADES-GS-z13-0 is one of the objects that help to understand what the first stages of galaxy formation looked like. Its existence confirms that several 100 million years after the beginning of the expansion of the universe, the first stable systems of stars began to appear. This is the time when hydrogen and helium gradually gathered under the influence of gravity, forming the first star-forming regions.
Within such early galaxies, processes occur rapidly and intensively. Gas clouds collapse under their own mass, reaching critical densities at which the birth of the first generations of stars is triggered. These stars differ from later ones. They form from almost primordial matter that contains almost no heavy elements. Their chemical composition is extremely simple, and the energy of the processes is extremely high. The radiation from such stars becomes a powerful source of ultraviolet light, which begins to change the surrounding intergalactic medium. It is during these epochs that a process known as cosmic reionization takes place, the transition of the universe from a state of opaque fog to a state where light is able to travel freely over vast distances.
JADES-GS-z13-0 is at the very center of these early processes. Its light shows that the formation of structures was faster than previously thought. There were already quite complex regions of star formation that could support the steady development of the galaxy, even in the conditions of a young and turbulent universe. Gas flows in such facilities are unstable. They are constantly shrinking, heating up, expanding again under the influence of the energy of newborn stars. This creates a dynamic environment in which the formation of new stars is continuous. Each new generation of stars changes the chemical composition of the surrounding space, gradually enriching it with heavier elements that will later become the basis for planetary systems of future epochs.
Despite its antiquity, JADES-GS-z13-0 shows signs of active star formation. This means that even at such an early period in cosmic history, galaxies could already support internal cycles of development. The energy released in these processes affects the shape and structure of the entire system, creating complex and uneven distributions of matter. At that time, the universe was much denser. The distances between the objects were smaller, and the interactions between them were more frequent and intense. Gravitational forces played a decisive role in the formation of the first clusters of matter, gradually uniting disparate clouds into stable structures.
Each such early galaxy becomes a kind of trace of the era when the foundations of all subsequent space architecture were laid. Over billions of years of evolution, these primordial structures will become part of larger systems, but their original nature is preserved in the deep characteristics of light as it continues its journey through expanding space. JADES-GS-z13-0 is one of the key objects for understanding how quickly the universe was able to move from a chaotic state to a structured one. Its existence indicates that the formation of galaxies may have begun earlier than previous models assumed.
Within its boundaries, the cycle of the birth and death of the first stars continues. Some stars are already completing their lives, enriching space with heavier elements, while others are just beginning to form from collapsing clouds of gas. This constant exchange of energy and matter forms the basis for the future development of the entire system. The light coming from such distant objects carries information about the earliest states of matter. It allows us to reconstruct the picture of how the universe moved from a simple distribution of matter to complex structures capable of supporting long-term evolution.
JADES-GS-z13-0 remains an important reference point in the study of deep space history. It shows that even in the earliest epochs, conditions already existed that could trigger the complex processes of galaxy formation that would eventually lead to the diverse cosmic structures observed today. And this light continues to move through expanding space, retaining information about the time when the first stars were just beginning to light up, and the universe itself was taking its first steps towards a complex and multi-layered structure.
As the universe expanded, the space around JADES-GS-z13-0 gradually became less dense, but within the galaxy itself, the processes only intensified. Huge streams of cold hydrogen continued to be pulled into its gravitational field, fueling new bursts of star formation. These streams moved through the cosmic web, a giant structure of invisible dark matter and gas that connected early galaxies to form a single system in the young universe. Dark matter played a decisive role in those eras. Without it, the substance would not be able to assemble quickly enough. It was the invisible gravitational frameworks that held the clouds of gas together, allowing the first galaxies to accumulate mass. JADES-GS-z13-0 was likely already inside such an ancient dark matter halo, which continued to grow and attract more and more material from the surrounding space. Within the galaxy, the birth of stars occurred at an incredible rate. Young, massive stars emitted colossal amounts of energy. Their ultraviolet radiation pierced the surrounding gas, tearing apart electrons and gradually turning the opaque early universe into a transparent one. Huge areas around the galaxy began to glow with ionized hydrogen. But these processes were unstable. The energy of the stars created shock waves that collided with new gas clouds. Some regions contracted even more, giving birth to new stars. Others, on the contrary, were destroyed by radiation flows. Within the young galaxy, colossal changes were constantly taking place. Space was filled with hot streams of plasma, powerful radiation, and giant turbulent structures. Some of the first stars in such galaxies could have been many times more massive than the Sun. Their existence was short but extremely vivid. They quickly burned their fuel and ended their lives with monstrous explosions. These first supernovae changed the chemical composition of the cosmos. It was after such explosions that carbon, oxygen,
Iron and other elements began to appear in the universe which almost did not exist before. Each such explosion threw matter over vast distances. Shock waves carried through the young galaxy, mixing hot elements with cold clouds of hydrogen. In this way, the very nature of the cosmos gradually changed. Simple primordial matter evolved into a more complex medium, capable of creating new types of stars and future planetary systems.
JADES-GS-z13-0 may be one of the first galaxies where this transition has already begun. Its light shows that chemical enrichment processes could have existed inside it much earlier than expected. This means that the evolution of the early universe was rapid. When observing such objects, another mystery arises. Many early galaxies appear too bright and too massive for their age. According to the old models, they simply should not have had enough time to accumulate such a mass. But the reality turns out to be different. In the first hundreds of millions of years, the cosmos developed faster and more intensively.
Some regions of the early universe were real centers of rapid formation of matter. In them, gas streams intersected especially actively, creating conditions for the rapid growth of galaxies. JADES-GS-z13-0 could be located in just such an area, inside an ancient node of the cosmic network where matter was collected most efficiently. The light of this galaxy also helps to understand the structure of early intergalactic space. When the photons left its limits, the universe still contained large amounts of neutral hydrogen. This hydrogen absorbed part of the radiation, leaving characteristic traces in the spectrum. From these traces, it is possible to determine the state of the cosmos in that era and understand how far the process of reionization has progressed. In fact, JADES-GS-z13-0 is a window into an era when the universe was just beginning to emerge from its ancient darkness. Before the appearance of the first stars, space was almost completely immersed in a cold, neutral gas. But then the first sources of radiation began to appear, gradually destroying this cosmic fog. Each early galaxy created a growing bubble of transparent space around it. These bubbles expanded, collided with each other, and eventually combined, completely changing the state of the universe. It is thanks to such objects that the cosmos has become as it is observed billions of years later. However, JADES-GS-z13 remains just one of many ancient systems hidden at extreme distances. Beyond the range of available observation, there may be even earlier galaxies whose light is just beginning its journey through space. Some of them could have formed even closer to the very beginning of the epoch of stars. The further one manages to look into space, the more the idea of the first stages of cosmic evolution changes. Previously, it seemed that the formation of galaxies should have happened slowly and gradually. But ancient objects show a completely different picture. The young universe was a place of colossal activity. Gas structures collided. Dark matter gathered matter into giant knots. Supermassive stars were born, and the first supernovae erupted. The cosmos of the early era was filled with energy. Everything was happening almost simultaneously, as if the universe itself was trying to move from chaos to complex structure as quickly as possible. And somewhere among these ancient streams of light, JADES-GS-z13-0 continues to shine. A tiny, distant, almost unreachable galaxy that existed when the universe was only a fraction of what it is now.
Its radiation still bears traces of an era when space was just beginning to be filled with the first stable lights and gigantic cosmic structures were just emerging inside the endless darkness. But even against the backdrop of other ancient objects, JADES-GS-z13-0 looks especially mysterious. Its light comes from such a distant epoch that almost the entire history of the cosmos lies between the moment of its emergence and the present time. During this time, galaxies changed, giant clusters collided, countless stars were born and disappeared, and space itself continued to expand continuously. When the radiation left the confines of this galaxy, the universe did not yet have the familiar modern appearance. Vast areas of space remained cold and dark. The light of early stars was just beginning to break through the dense clouds of neutral hydrogen. Each new galaxy became a source of energy that changed the surrounding space. Inside JADES-GS-z13-0, the temperature in the active regions could reach colossal values. Young, massive stars heated the gas to millions of degrees. Streams of charged particles permeated the galaxy, creating an unstable environment where matter continuously transitioned from one state to another. Some of the gas cooled and contracted again, forming new dense clouds. Inside these clouds, gravity caused the birth of the next generations of stars. This process created a continuous chain of cosmic evolution. Each new star changed the surrounding space, and space in turn influenced the birth of the next objects. In the early universe, everything happened faster. Galaxies grew rapidly because there was a huge amount of free gas around them. Space has not yet been depleted by billions of years of star formation. Matter was easily drawn into the gravity centers, increasing the growth of young systems. The JADES-GS-z13-0 could increase its mass almost continuously. Streams of matter penetrated into it along the filaments of the cosmic network, fueling internal processes. These giant filaments stretched across the early universe for enormous distances, connecting young galaxies with each other.
Where the filaments intersected, areas of particularly high density appeared. It is in such regions that giant clusters of galaxies will later appear. It is possible that JADES-GS-z13-0 is located inside one of the oldest such nodes, in a place where the cosmic structure was just beginning to form. Some observations indicate that early galaxies may have been much more compact than modern galaxies. Their size remained relatively small, but there was a huge amount of energy concentrated inside. This made the star formation processes incredibly intense. The space inside such systems was literally saturated with radiation. Due to its vast distances, the light of JADES-GS-z13-0 changed dramatically as it traveled through the expanding universe. The wavelengths stretched, shifting the radiation to the infrared. That is why ancient galaxies cannot be seen with conventional observation methods. Their light is no longer the same as it was at the moment of their origin. Each photon of this galaxy carries information about the early state of the cosmos. In the spectrum of light, traces of chemical elements, gas temperature, environmental density, and the rate of star formation are hidden. These data make it possible to reconstruct the appearance of the ancient universe. The issue of the appearance of the first supermassive black holes remains especially important.
Some early galaxies already contained objects with masses of millions or even billions of solar masses. It is still unknown how such giants were able to form so quickly. It is possible that the processes associated with the birth of an early supermassive object are also taking place inside JADES-GS-z13-0. If a rapidly growing black hole already exists at its center, it could have a significant impact on the entire galaxy. Huge volumes of matter falling inside are heated to extreme temperatures and begin to emit a colossal amount of energy. This radiation is able to push gas outward, slowing down further star formation.
This is how a complex balance arises between the birth of stars and destructive energy flows. Inside the young galaxy, there is a constant struggle between gravity, which seeks to compress matter, and radiation, which tries to scatter it back into space. Sometimes, shock waves from supernovae and active nuclei create giant voids inside galaxies. Hot gas bursts out, forming powerful streams that go into intergalactic space. These emissions carry heavy elements far beyond the galaxy, gradually changing the chemical composition of the entire universe.
In early epochs, such processes played a huge role. The cosmos was gradually filled with matter that would later become the basis for the formation of new stars, planets, and the complex structures of future ages. It was ancient galaxies that first began to transform the originally simple composition of the universe into a more diverse one. But even now, there are many unknowns. Some parameters of the JADES-GS-z13-0 are controversial. Perhaps her age is even older than supposed. Perhaps its structure is much more complex. With each new analysis, additional details emerge that change the way we think about the early cosmos.
And the deeper the observation becomes, the more clearly the amazing feature of the young universe is manifested. It was not slow and empty. It was stormy, bright, and saturated with processes of a colossal scale. Already in the first hundreds of millions of years, systems arose inside the cosmos that were able to rapidly accumulate mass, form stars, and change the surrounding space. The light of JADES-GS-z13-0 continues to travel through infinite distances, preserving traces of a time when galaxies were just beginning to exist, and space had not yet had time to take on the appearance that will become familiar after billions of years of cosmic evolution.
And the further the study of ancient space continues, the stronger the feeling becomes that JADES-GS-z13-0 is not just a distant galaxy, but one of the surviving traces of the very beginning of great space history. Its light originated in an era when the universe was just forming the first stable structures, when space remained young, hot, and filled with the continuous movement of matter. Over billions of years, the galaxy itself has inevitably changed. The first stars have long since disappeared. Huge clouds of gas have either evolved into new generations of luminaries, or have been ejected into intergalactic space by powerful streams of energy. Perhaps a small ancient system gradually merged with other galaxies, increasing its mass and changing shape. Perhaps its structure became part of a larger cosmic formation, hidden today behind incredible distances.
But the light that had left it in that ancient era continued to move through the expanding universe. It crossed gigantic regions of space, past galaxy clusters, dark matter fields, and regions of intergalactic gas. Space was stretched, changing the radiation itself, but information about the distant past was still stored inside each photon. That is why JADES-GS-z13-0 has become so important for understanding the origin of cosmic structures. It shows that already in the early universe, there were processes of enormous power. Gravity rapidly gathered matter into the first galaxies. Massive stars were born. Sources of colossal radiation were formed. The cosmos emerged from its primordial darkness and was gradually filled with light.
This ancient galaxy is a reminder of how deep the past of the universe is. Beyond the usual starry sky, there is a story that goes back to the very first epochs of the existence of matter. A history of a time when there were no mature galaxies, huge spiral structures and complex clusters. Only the first islands of light in the infinite young space. And perhaps, beyond the boundaries of already discovered objects, there are even more ancient systems, even fainter signals from an epoch close to the very beginning of the stars.
Each new object expands the boundaries of what is known and shows that the early universe was much more active, complex, and brighter than previously thought. JADES-GS-z13-1 remains one of the oldest known lights in the cosmos. Its radiation is a direct trace of the time when the universe was just beginning to build its first galaxies. Light, which has survived almost the entire history of space, continues to carry information about the birth of the cosmic structure, about the first flows of energy, about the beginning of the age of stars, and about the moment when the darkness of the ancient universe gradually gave way to light.